The human brain operates on a fundamental paradox. It is simultaneously a computational device of immense power, capable of abstract thought and complex modeling, yet it is also a master of cognitive conservation, relentlessly seeking to minimize effort. This apparent contradiction is central to its functional design. The mental shortcuts it employs are not flaws in its logic, but rather essential, highly evolved strategies for navigating an overwhelmingly complex world with finite processing capacity. These cognitive strategies, known as heuristics, represent an elegant solution to the problem of efficiency. They allow for rapid, intuitive judgments that are sufficient for most situations, bypassing the need for exhaustive, energy-intensive analysis. Understanding this system is not about identifying intellectual defects. It is about recognizing the brain's inherent pragmatism, its solution to the challenge of making effective decisions under conditions of uncertainty and time pressure. To grasp the necessity of these shortcuts, one must first appreciate the scale of the brain's data processing challenge. The human sensory system transmits approximately 11 million bits of information to the brain every second. This includes everything from visual data to ambient sounds and tactile sensations. This torrent of information must be processed and interpreted in real time. However, the brain's capacity for conscious, deliberate processing is estimated to be only around 50 bits per second. This vast disparity between sensory input and conscious bandwidth necessitates a powerful filtering and simplification mechanism. The brain cannot afford to analyze every piece of data. It must prioritize, approximate, and infer, creating a simplified model of reality that is functional, if not perfectly accurate. These approximation methods are known as heuristics. A heuristic is a cognitive rule of thumb or a mental shortcut that facilitates rapid problem-solving and judgment. It is a fast, intuitive process that operates largely outside of conscious awareness. This stands in direct contrast to an algorithm. An algorithm is a deliberate step-by-step procedure that guarantees a correct and optimal solution if followed precisely. Consider the task of navigating an unfamiliar city. An algorithmic approach would involve consulting a map to analyze every possible route, calculating distances and travel times to determine the single most efficient path. A heuristic approach might be to simply walk in the direction of the tallest, most prominent landmark. The algorithm guarantees the best result but is slow and requires significant mental effort. The heuristic is fast, requires minimal effort, and provides a solution that is often sufficient even if it is not technically optimal. This trade-off between accuracy and speed is the defining characteristic of heuristic processing. The brain overwhelmingly favors the heuristic approach for routine decisions. One of the most fundamental of these shortcuts is the availability heuristic. This principle describes our tendency to assess the likelihood of an event based on the ease with which examples come to mind. If instances of something are easily retrieved from memory, we perceive that thing as being more common or more probable. This mechanism explains why certain low-probability risks are systematically overestimated. For example, media coverage makes instances of shark attacks vivid and easily recalled. Consequently, the perceived risk of a shark attack is often inflated, while the statistically higher but less memorable risk of being killed by falling airplane parts is underestimated. The heuristic operates not on objective statistical reality, but on the cognitive ease of information retrieval. Information that is recent, emotionally charged, or frequently repeated becomes more mentally available. This availability creates a cognitive illusion of high frequency, demonstrating how the brain's shortcut substitutes a simple question, "How easily can I think of an example?" for a much more complex one regarding statistical probability. The implications of the availability heuristic extend beyond personal risk assessment. This cognitive shortcut is a foundational tool in marketing and strategic communication. Repeated exposure to a brand or message increases its cognitive availability, making it feel more familiar, common, and trustworthy, irrespective of its objective quality. This mechanism builds brand equity by embedding a product into the consumer's readily accessible mental library. In organizational management, this same heuristic manifests as recency bias. A manager conducting an annual performance review may unconsciously overvalue an employee's performance from the last few weeks, as those memories are most available. This can overshadow months of consistent, high-quality work, leading to skewed and inaccurate evaluations. The brain defaults to what is recent, not what is representative. Further analysis reveals a more fundamental mechanism. We now turn to the representativeness heuristic. This mental shortcut involves making judgments by comparing a current situation or individual to a pre-existing mental prototype or stereotype. If an object or person seems to represent a particular category, the brain rapidly classifies it as such, often ignoring base-rate statistical information. The definitive illustration of this is the Linda problem, a thought experiment developed by psychologists Daniel Kahneman and Amos Tversky. Participants are given a description of a woman named Linda, who is outspoken, bright, and deeply concerned with social justice. They are then asked which is more probable, that Linda is a bank teller, or that Linda is a bank teller and is active in the feminist movement. A significant majority chooses the second option. This is a logical error. The probability of two events occurring together, the conjunction, is always less than or equal to the probability of either one occurring alone. The description of Linda simply matches the mental prototype of a feminist more closely than that of a bank teller, causing the brain to favor the more representative, yet statistically less probable scenario. The impact of the representativeness heuristic is substantial in high-stakes professional fields. In medicine, a physician might misdiagnose a patient whose symptoms are atypical for a common disease because the presentation does not match the textbook prototype. The shortcut bypasses a more thorough, data-driven diagnostic process. Similarly, this heuristic influences financial investments. An investor might overvalue a startup because its founders fit the popular stereotype of a successful tech entrepreneur, young, confident, from a specific academic background. This judgment, based on representation, can supplant rigorous analysis of the company's actual business model, market viability, and financial data. A third critical shortcut is the anchoring and adjustment heuristic. This cognitive bias describes the brain's tendency to rely too heavily on the first piece of information offered, the anchor, when making decisions. Subsequent judgments are not made in isolation. They are adjustments from that initial reference point, regardless of its validity. In negotiation, the initial offer sets a powerful anchor. If a seller asks a high price for a car, the buyer's perception of the car's value is immediately skewed upward. All subsequent counteroffers will be adjustments from that high anchor, likely resulting in a final price that is higher than if the initial anchor had been more moderate. The anchoring effect permeates economic and legal decisions. In retail, a high manufacturer's suggested retail price makes a discounted sale price appear far more attractive. In a courtroom, a prosecutor's demand for a long sentence can anchor a judge's final decision, even if the judge consciously tries to disregard it. The initial number establishes a cognitive boundary for all subsequent reasoning. These individual heuristics are not isolated flaws. They are manifestations of a coherent, underlying cognitive architecture. This framework is elegantly described by dual process theory, which posits two distinct modes of thinking operating within the mind. This model unifies the seemingly disparate shortcuts into a single, functional system. The first mode, designated System 1, operates automatically and rapidly, with little or no effort and no sense of voluntary control. It is the source of our intuitions, immediate impressions, and the heuristic shortcuts previously examined. System 1 continuously generates suggestions for the more deliberate mind. In contrast, System 2 allocates attention to the effortful mental activities that demand it, including complex computations and logical reasoning. It is slow, analytical, and deliberate, representing the conscious, reasoning self. This system is activated when a problem exceeds the capabilities of System 1, or when an intuitive error is detected. The existence of this dual system is not an accident of evolution. It is a profound adaptation for resource management. The human brain constitutes approximately 2% of total body mass. It consumes a disproportionate 20% of the body's metabolic energy. Engaging the analytical system 2 is metabolically expensive. Heuristics, as the primary tools of System 1, are therefore an elegant evolutionary strategy for energy conservation. They allow for rapid, effective decisions that ensure survival without depleting vital cognitive resources on every single input. This understanding directly informs the practice of cognitive debiasing. This is the conscious act of recognizing a potential System 1 error and deliberately engaging System 2 to override the intuitive, but potentially flawed judgment. It is a methodical check on automatic thinking. For instance, when evaluating a major financial investment, an awareness of the anchoring heuristic prompts a strategic thinker to discard the initial price. They engage System 2 to conduct an objective valuation based on fundamental data. This mitigates the initial anchor's irrational influence. The purpose of understanding heuristics is therefore not to condemn the brain for its inherent flaws. It is to appreciate the profound elegance of its efficiency model, a system optimized over millennia to balance accuracy with speed. These shortcuts are functional adaptations. These cognitive shortcuts are the very foundation of our ability to navigate a complex world with finite mental capacity. The ultimate intellectual skill is not the elimination of heuristics, but the wisdom to discern when to trust the efficiency of System 1 and when to invest the energy required for the precision of System 2. The application of this knowledge extends beyond individual self-awareness into systemic analysis. In behavioral economics, for example, heuristic-driven behavior is not an anomaly, but a predictable variable that shapes entire markets. The assumption of a purely rational actor has been largely superseded by models that incorporate these cognitive shortcuts to explain market inefficiencies and bubbles. One can observe this in the disposition effect, a documented tendency for investors to sell assets that have increased in value while holding assets that have dropped. This behavior is inconsistent with rational financial theory, but is perfectly explained by loss aversion, a powerful heuristic where the psychological impact of a loss is felt more acutely than an equivalent gain. The shortcut is to avoid realizing a loss, even when data suggests it is the optimal action. The aggregate consequence of such individual biases is significant. They contribute to market momentum and volatility, where asset prices deviate from their fundamental values for extended periods. This demonstrates how micro-level cognitive shortcuts can scale up to create macro-level economic phenomena, challenging the notion of perfectly efficient markets. This scaling effect is also visible in herd behavior, a phenomenon where individuals follow the actions of a larger group. This can be understood as a large-scale manifestation of the availability and representativeness heuristics. When a particular investment strategy becomes highly visible and appears successful for others, it becomes a readily available mental model that individuals adopt, often bypassing rigorous independent analysis. The implications are equally profound in high-stakes professions such as medicine. Physicians operating under severe time constraints and cognitive load frequently rely on heuristics to make rapid diagnostic judgments. While often effective, this reliance introduces specific, predictable vulnerabilities into the diagnostic process. A clear example is diagnostic error driven by the availability heuristic. A physician who has recently treated a patient with a rare disease may be unconsciously primed to see its symptoms in subsequent patients, potentially overlooking a more common but less salient diagnosis. This cognitive shortcut prioritizes recent experience over statistical probability. The systemic consequence is the potential for misdiagnosis and delayed treatment. To mitigate this, modern medical practice increasingly incorporates algorithmic checks and balances. Formalized differential diagnosis procedures and evidence-based clinical guidelines act as a deliberate System 2 override to the intuitive, heuristic-driven judgments of System 1 thinking. Further analysis reveals that understanding these innate human biases is fundamental to designing effective artificial intelligence. AI systems can be developed to either augment human intuition or to serve as a corrective mechanism against its known failure modes. This creates a new frontier in human-computer interaction. Two distinct design philosophies emerge from this understanding. Augmentation systems leverage AI to rapidly process vast datasets, presenting distilled insights that align with and enhance the user's intuitive cognitive flow. In contrast, Countermeasure systems are designed to actively monitor and flag decisions that show patterns consistent with common cognitive biases, prompting the user to engage in more deliberate, analytical thought. Ultimately, the study of heuristics transcends a mere description of mental processes. It becomes a prescriptive framework for engineering better decision-making environments. By understanding the architecture of our cognitive shortcuts, we can design systems, protocols, and technologies that compensate for their limitations, thereby refining and elevating our collective capacity for judgment.